now. Let's see. Oh, there you go. Share. All right. Yeah, you should be able to see me live on YouTube if you go to YouTube. What's the best way to teach college algebra? Because my teacher, when I actually teach Ashton, it depends on. I normally say it depends on how you learn. For me, it's video. For you, it might be, you know, it might be reading. Uh, so if you learn, if you can read the stuff and understand it, you have to start with that first. The inverse of a function, Shane. If we have some time, we'll talk about it. If you if you learn better by reading, you have to start with that first, and then the second thing that's the most important is practice, and that's how you'll be able to do it. So if you learn better, just watching videos, you watch video about it, no problem, Shane. And then after that, you have to practice. If you don't, there's no point of watching a bunch of stuff that you don't actually do it. And it works like that in anything else too. Anything that you're trying to do, you learn about it and then you practice it, and that's how you truly learn and know it. Certain stuff. The only reason. Oh man, I'm sorry to hear that you fell in math, my man. How can I help? That works in anything else. So the only way you truly know it is just by doing it. You do it over and over and over. Eventually, it's state. So that's what I would say, Shane. Whoever asked the question about college algebra, I don't think it was Shane. So let's talk about something very simple that you guys may see on in class. I am hot. So let's talk about some simple stuff that you've seen in class. And I know I've seen a lot of kids have problem with this, and I want to help with it today in a little bit before I answer other questions that you guys may have. So we're going to talk about similar triangles. So let me put in this red here. To see the screen, you guys know the drill already. Just go on YouTube and you'll be able to see it. So let me put this one here. I'll make it big so you guys can. Actually, I won't do a. Now I have to find a measure, exact measure. Let's see, similar triangles. So we have a triangle this way, and I know, and let me have a line. Let me put a line right here somewhere. I have to make sure that this is right in terms of Pythagorean theorem. Let's see. So we don't have to do a right triangle. Let me do a different triangle. See if I have a regular triangle here that doesn't look right. No. Okay. All right. So pretend that this is not a right triangle. And I wanna actually, you could do this. I don't have to do this. So let's say that you have a regular a triangle that has, this is this way. You have this here, and then you have a side here that's this. So let's say you know the length of this side, which is 5, and you know this one is 7. So you know this side is 7, and you also, this whole thing is 7. And let's say this one is what, 9 maybe. And then you want to know, let's see. All right. So let's say I have this side, 1, 5. Are you guys able to see the screen on YouTube? Gotta go YouTube to see it. I am not teaching a class. I have courses. What math class are you failing? Is it algebra, geometry, trig, calculus? What is it? What math class are you feeling? So let's say we know this is 5. This is trying to set this up in a certain way so you guys can understand. So let's say we know this is 6, this is 4, and we know this one is 3. So let's say you try to know what's the length of this side of the triangle, and we want to use similar triangles to find the length of this whole side. Let me put it in blue so you can understand what I'm saying. So let's say you want to know the length of this whole side in the triangle. So this is the side in blue that we want to know the length of it. So how do we find the length of this side? Using similar triangles. And I think we have all the information that we need here. So what similar triangles says is, if I have the two triangles that all, kind of look the same, and there is a relationship that can give us, if we have one side, if we know the one side or a few of the sides, there's a relationship between all the sides in the triangle that can give us a side if we have one. And let me explain this a little bit better. So in this triangle right here, I'll call this A, B, C, D, and E. Now, what similar triangles says is the sides that kind of look alike, there's a relationship between in the length. So what I'm saying is, this side, if I take this side of the triangle, I can consider the triangle ABC, right? ABC. If I consider this triangle in blue, this side BE is how much? Who can tell me how much BE is? Come on, guys. If you want to see the screen, you got to go to YouTube to see it. Who can tell me how much the side BE is? Who's with me? Anyone? Yeah, you got to go to YouTube to see the screen. Okay, so how much the side BE is the side BD, which is 4, plus BD, which is 4, plus DE, which is the length of BD, the length of this side, which is 4, and then the length of the other one, DE, that's D, which is 6. So we have 4 plus a 6. The side BE is how much? Come on, guys. Hey, what's up? Robert. Robert? All right, so that's 10, right? That's 10. So now we know the side AB is 5. So similar triangles say, if I consider this triangle ABE, it's almost the same as the triangle CDE. Let me write this triangle in a different color. CDE, CDE. So the triangle ABC, which is the big triangle, is similar to the triangle, and I'm saying those two lines are parallel. Those two segments are parallel. So AB, the line that goes, that this line and this line, this segment and this segment are parallel. That's what makes them similar triangle. So what I'm saying is ABE and CDE are similar triangles. So now what does that tell us about the relationship between all the sides? So if I take this side 3 over So if I take the length of this side, oh, that's not what I wanted to do. If I take the length of this side, BE, over AB is the same in the small triangle. So the length of BE is this outside length right here. So in that small triangle, it corresponds to this length outside right here. It corresponds to this. In the smaller triangle, it corresponds to this. So BE is the whole thing for the big triangle. For the small triangle is that little small thing. So it's gonna be the same as this little small thing, DE, over that side for the big triangle AB is the same as this small side for this triangle, which is CD. Am I making sense, guys? Let me know if you have any questions. And am I making sense? Yes, no, maybe. All right, cool. So what did I say? So I consider the two triangles A, B, E, which is the really big triangle, and the triangle C, D, E. I say those two triangles are similar triangles. So what that mean by that is if I take the ratio of this side right here, the ratio of similar sides are equal to each other. That's what it says. That's what it means by having similar triangle. The ratio of similar sides are equal to each other. So the ratio of sides that kind of look alike are equal to each other. So what's the ratio of this side, which is, the one on the outside right here? Maybe I could color them in different colors so you guys understand what I'm saying. So let me make 3 different colors for them. So I have a purple for this side. Let me see. I'm gonna color this side purple for both triangles, and I'm gonna color this side blue for both triangles, and I'm gonna color this side black maybe for both triangles. And then, so if this was blue, this is also blue. So black right here. If this was blue, this is also blue. The side that's parallel to it is blue. So what I did is I named them. E was here. And then what else did we name them? This side was A, B, C, D. So A, B, A. And it's the same thing. I'm just rewriting it so you guys understand what I mean by the ratio of the sides that are similar equal to each other. A, B, C, D. Now, here's what I said. So ratio of sides that are similar in similar triangle, they basically equal to each other. So if I take the purple side, the big purple side, the purple side in the big triangle, which is what? What's the purple side in the big triangle? You can tell me what's the purple side in the big triangle? It was what? A, BE, right? BE. If I take that ratio over the blue side in the big triangle, which is AB, that ratio is going to be the same as the purple side in the small triangle divided by the blue side in the small triangle. The purple side in the small triangle is what? What's the length of purple side in the small triangle is what? As DE, and the blue side in the small triangle is CD. Okay. Now once you have this relationship, it's easy to find the length of the side that's missing. So let me see if you guys have any questions. Questions? Yes, no, maybe. Okay, so what's the length of what was the length of just 4, 6, 6, 5, 3. I named 4, 6, 5, 3. So this one was 4, this one was 6, this one was 5, this one was 3. Now, okay. Now how do we find the length of? So what the one that I was looking for is, I know BE, which is 4 plus 6, which is 10. I know this one is 10. I know whichever the other one was, the one in purple, the BE is 10. I know BE is 10. I also know that AB is 5. And then I know the length of DE, nope, 6. And I want to know the length of C. No, I already have those. Okay, so if I wanted to know the length of CD, that would be what? 10. I think I picked those right. 10 divided by 5 is equal to 6. DE 6 over CD, which is 3. Wow, I picked those really well. So let's say if I wanted to know the length of if I wanted to know the length of let's say I wanted to know the length of AC maybe, and based on that relationship, you can also find the length of AC. You can also find the length of AE, whichever one you didn't have. So let's say I didn't know how much this was. If I didn't know how much CD was, which I already give you guys. So if I didn't know how much CD was, so what I would do is the length of BE, which is BE, which is 10, divided by, BE is 10, 4 here and 6 here, plus 4 plus 6 is 10, divided by the length of AD is 5. That would equal to the length of the second triangle that I'm considering is ACD, 6, over the corresponding blue side for the small triangle, which would be X. Now, when you solve for X, X would be 3. And yeah, 10 over 5, which is 2. 2X, X is 3. So the way you solve for this, you cross multiply. 10X is equal to 30 times 6 times 5 is 30. You divide both sides by 10. X is equal to 3. And that's how you'd solve for this one. And that would give you the length of the side CD. I gave you the answer before I did the problem. Okay, so what else you guys want to see? I think somebody asked about the inverse of a function. So let's say I have a function. Say if I know f of x is equal to 3x plus 5. And I want to know the inverse of this function, and assuming that we're in R. So normally what you would do is solving for x. If the function is 1 to 1, if you don't have any conditions, or if you know the conditions and you solving it in that interval within that condition, you just solve for x. So what you do is you replace the f of x by y. You say y is equal to 3x plus 5. So what you do is you'd add 5 to both sides. Take away 5 from both sides. 5 minus 5 is equal to 3x. And then you divide both sides by 3. Let me scroll up. I divide both sides by 3. Divide this side by 3. Divide this side by 3. So that means x is equal to y minus 5 divided by 3. And the way that normally they write this, normally they would say f inverse of x is equal to y minus 5 divided by 3. Is it f inverse of x or y? Not sure. But yeah, is it f inverse of x or y? I'm not sure if this is y or x. I forgot. So what normally is, so the process is, I forgot who asked this question. Let me see who asked the question. I'm trying to find who asked this question. So what you would do is you solve for the other variable. So if they give you function y f of x, you can use those interchangeably. Y is equal to f of x. Let's go to 3x minus 5. So what you would do is say, okay, I'm going to replace the f of x by y, and then I'm going to solve for that variable x, and that would give you the inverse function. And that's how you solve for it. That's how you solve for the inverse function of y. Y is equal to f of x. Yeah, I think it's f of x is equal to, said that would means y minus 5 divided by 3. So what that entails is, so let's say if I had a point 0, if 0 was mapped to, in the function f of x, f of 0 was what? F of 0 was 5. F of 0 is equal to 5 because you replace x by 0. 3 times 0 plus 5 is equal to 5, right? Now, so the point 0, 5 is a point of this function f of x. What if you want to know the point? So what does that say about this function f inverse of x? This function f inverse of x. So f inverse of x, this function has y minus 5 divided by 3, right? So how do you solve for, so what's the coordinate, so in the function f of x, there was a point 0. 0 matches 5. There was a point 0, 5. Now in this function, 5 gonna match to 0 because it's the inverse function. So this function, if I replace y by 5, y is equal to 5. 5 minus 5 is 0. 0 divided by 3 is 5. It's 0. So 5, 0. That's what it's the inverse function. So whatever x, you flip the x and a y. That's why it, that's why you have an inverse function. So point here was 5, 0. 0 was mapped to 5 when we had a function f of x. When in the function f inverse of x, 5 is mapped to 0. So if I replace the variable here by 5, and you got to understand this becomes the variable. If I replace this by 5, and I get a 0 for the output. Make sense? All right. What else you guys want to see? Anything else, guys? Let me see if you guys have any questions on TikTok. I appreciate you, Money. I appreciate you. Thanks, man. All right. Let me see if you guys have any questions. Anything else you want me to talk about? Welcome, Janelle, Olivia. Oscar. All right. You guys have any questions? Okay. Janelle, I'm trying to understand your question. Are you trying to multiply a binomial by a polynomial? Is that what you're trying to do? No problem, Amy. Okay, you're trying to multiply a binomial by a polynomial. Okay, so let's say that we have, so you know what those terms mean. Monomials, binomials, and polynomials. Let me review. So monomial means monomial, however they call it, means one term. You don't have more. You have one term. So in a polynomial, you can have multiple terms: 4x squared plus 3x to the third plus 6x to the ninth, actually not negative, minus 5. So that's considered a polynomial. So polynomial is, multiple terms. You have 4 terms, 5 terms, multiple terms. It's a polynomial. But if I take the first 2 terms, so if I take 3x to the third plus x squared, that's a binomial because it has 1 term and 2 terms. This could be minus. Now, the caveat is if the exponents needs to be at least 0. This is considered like x to the 0. So what I'm saying, the exponent cannot be negative. So if you have a -2 here, this is not a polynomial. It's not considered a polynomial. So what I'm saying, if x to the -2 is not considered a monomial, or plus x squared, this is not considered a binomial because you have a negative exponent here. The exponents have to be non-negative. Now, so I think that you get that term. Monomial, is 1 term. So 2x squared, that's a monomial. Negative 5x. Don't confuse the exponents and the coefficient. The coefficient can be negative, but the exponents cannot be negative. So these are considered monomials. And 1 term. 2 terms, binomial. So if I have 3x squared plus 5x, that's a binomial. 2 terms. Multiple terms, polynomial. A binomial is also a polynomial too because it has more than 1 term. It's like multiple. So 2 is considered multiple. So now let's say you want to multiply a binomial. I'll show you how you do it normally, how I normally do it. And I think it's easier for me even if I'm multiplying 2 binomials. Let's say I have x plus 5. I'm multiplying that by x minus 7. You guys are used to like the FOIL method, but for me, I find it easier if I start with x and I multiply it by everything in here. And then after that, I take the 5, I multiply it by everything in the second parenthesis. I'm going to do that with that, and then I'm going to do a binomial times the polynomial so you can understand better. So the first thing that I'm going to do is take the x multiplied by the x, which is x squared, x times x. So this x times this x, which is x squared. And I take this x, I multiply it by 7, which is by -7, which is -7x. Now, let me change color so you understand that I'm switching. Now I take the 5, I multiply it by x, which is 5x plus 5x. And I take the 5, I multiply it by -7, which is minus 35, correct? 35. Welcome, Seth, Doni, Espino, Hannah. So 7 times 5 is 35, correct? So now, and then I group like terms, x squared minus 2x minus 35. And I think this should be the answer for this one. Now, you notice how I did this. So I take the x, and in that way I don't get confused. I don't want to get confused into saying, and that's how I learned them myself. If you used to using the FOIL method, that's also good too. But efficient, and I find it easier than the FOIL method. Okay, substituting the coefficient, I find it easier than the FOIL method. Okay, what you mean by substitution of the coefficient? If you could elaborate on that. But this is how normally I would use it. I'm not sure if you're referring to the same method that I'm saying. This is normally how I would use it. The first thing I do is saying, okay, I'm going to start with x, and I'm multiplying by x by everything else. Okay, like how I did it with x. Yeah, good. So yeah, I find this easier too, Janelle. We're on the same page. I start with x, I multiplied by everything else, and then I take on 5, I take on and whatever else was there. So now it's the same thing if you have a binomial times a polynomial. So let's say I have x squared plus 5x, and I'm going to multiply that by x to the third minus 3x squared plus 6. And that's a polynomial. That's a binomial. I mean, they are both considered polynomial, to be honest. So now, how do we do this? We start with the one term. So let me start with this. Let me do this in a different color. So I start with, I think this is purple, x squared. So I'm going to multiply x squared by this guy. I'm going to multiply x squared by this guy. The first one, x squared times x to the third is x to the fifth, right? And I take that x squared, I'm going to multiply it by negative 3x squared. X squared times x squared is x to the fourth times the negative coefficient that was in front of it, negative 3x to the fourth. Okay, and I'm still using x squared because if you were using FOIL method, I don't even know if there is a a version for this. Eduardo, Alexa, welcome. So I still continue to use the x squared. So I'm going to take that x squared multiplied by 6x squared plus 6x squared. Now I'm done with x. I don't have to use it anymore. So I'm done with x. And if you guys want to see the screen, please go on YouTube. You can just go on my profile and you'll see the YouTube page, the link to the YouTube page. No problem. No problem. So I start with x. I multiply x by everything else in that side, and then I take the 5x started with x squared. Now I take the 5x. I multiply by everything else on that side. 5x times x to the third is plus 5x to the fourth. And I take the 5x again. I multiply it by negative 3x squared. X times x squared is x to the third. 5 times negative 3 is negative 15x to the third. And then I take that 5x again. I multiply it by, let me bring the screen down so you can understand. I take the 5x again. I multiply it by 6. 5x multiplied by 6 is 30x. 30x. Now, let me see if any mistakes. X to the fifth, negative 3x to the fourth, 6x squared, 5x to the fourth, negative 15x to the third, 30x. Now, okay. It's Michelle. Yes, I do tutor calculations as well. But I don't really have a whole lot of requests for it here, to be honest. But I do tutor calculus. Every now and then you get a question about it. But yeah, I do tutor calculus as well. So now, what do? We group all the terms together, like terms together. So, and I can use a different color even if I wanted to. So I have x to the fifth. That's the only guy that's x to the fifth. So I leave it by itself. And then I have negative 3x to the fourth plus 5x to the fourth plus 2x to the fourth. And then I have 6x to the 6x squared. And I don't think I have any other x squared plus 6x squared. And I'm supposed to do the x to the third first. X to the third. So I have x to the fifth, x to the fourth all gone, 2x to the fourth. Now let's do x to the third. Negative 15x to the third. Let me bring the screen down so you understand. Negative 15x to the third. And that's the only one that I have, minus 15x to the third. And x squared, 6x squared, plus 6x squared. And then what else did I have? And then this term in x, 30x. And I think that should do it for this one. That should do it for this one. So that's how you multiply a polynomial by a binomial. And I would start with one term, Janelle. I would start with one term from this and multiply it through. And then after that, I take the second term and multiply it through. If you know a different method, they should arrive to the same solution. Yeah. Okay, these set it up in standard form. Okay, so now in standard form, what it means is the exponents are going in decreasing order. So what it means is x to the fifth, you're gonna put that first, and then you put the fourth or whatever come next. If you don't have a fourth, you have a third, you just put the third. And this is in standard form. This is 3, this is 2. Notice when I was doing the 2 before the 3, I just switch it because I wanted to put it in standard form. Yes, it is in standard form. So 3, 1. So you see 5, 4, 3, 2, 1. And that's in standard third. So the highest degree in first, and then you put the other degree. So if they already asked you a question, what is the degree of this polynomial? It's the highest degree in here. Degree of the polynomial is 5. So you start with 5. So when you put it in standard term, 5, 4, 3, 2, 1. No problem, Janelle. Yeah. So that's in standard term. Any questions about this or about something else? Any questions, guys? No problem, Janelle. If you know me, no, don't. Welcome. Some clever name. All right, guys. Anything else that you want me to help with? Are you guys still in school? I mean, let me know what you guys are doing. Is it homeschool, or are you going to class? Are you doing virtual school? Let me see what you guys got going on. Who's still going to school? Yeah, it's like we started Invisible Eyes. It's like one eye. Virtual. Okay, it's virtual. All right, online Zoom school for me. That's what's up, Michelle. Okay, I'm not sure what you asked. What you asking, Janelle? Invisible. I'm not sure what you're asking. Yes, it doesn't make a whole lot of sense. I'm not sure what you're asking. Yeah. So that's how you would solve for this one, and I think this is it. So you guys don't seem to have any questions tonight. Imaginary. Okay, that's probably what you were saying. Okay, imaginary numbers and stuff. Hey, thank you, HM. Thank you. Imaginary. Yeah, that's what you were saying. So imaginary numbers. Thank you for sharing the live video, man. Thank you. Hey, what's up? What's going on, man? Theo. Yeah. So yes, okay. Imaginary numbers. I'm gonna give you a little trick, and I think we've done that here before, and you will remember all of them when you anytime they ask you to raise it to a certain power, you'll remember what to do. So let's say, so if it's imaginary, just let it not exist. I know, right? So let's say that you have, so let's say we want to raise, but let me start. First, let's say we know the imaginary number I. So some of you guys, you call it square root of -1, and some other book, they define I squared is equal to, what is it? I squared is equal to -1. So either way, it's the same thing. I squared is equal to -1. I is equal to square root of -1. It's kind of like the same thing. So now let's say that we wanted to raise those to a certain power. So let's say if I walk up to you, Janelle, and say, what's I to the 2,000? And then you probably, yeah. So let me give you a little bit of review. Hopefully that helps you understand it a little bit better. So let's say somebody come to you, your teacher, or I see you on the street, Janelle, and I say, hey, what's I to the 2000? And in your head, it might take you a long time to calculate it. You might say, oh man, I don't know what this is. So I would multiply I by itself 2000 times, and I don't have enough time to tell you the answer, and I'll get back to you. Now, there's an easy way, there's a trick. So let me show you where the trick is coming from. So let's say I have I, let me use a different color, I, and I multiplied by another I. What's I times I? Yeah, I'll show you how to find the answer to those really quick. You'll see. What's I times I? And you could solve this in less than 30 seconds. I'll show you how to solve this in less than 30 seconds. Gianna, welcome. So what's I times I? I times I is I squared. And as by definition, we know I squared is -1. Okay, -1. Cool. Now, what is I to the third? I to the third is I squared times another I, which is the -1. I can replace the I squared by -1, which is -1 times I. What does that give you? What does that give you? What's I to the third? -1 times I. What does that give you, Janelle? Anyone? Come on, guys. I to the third, -1 times I, which is what? -1 multiplied by I, which is negative I. Negative I. I don't know if this is lagging, but yeah, it's negative I. So what is I to the fourth? It is I to the fourth. It is what? You could say it's I to the third times I, or you could also say it's what? You could also say it's I squared times I squared. I squared is equal to -1 times another I squared, which is equal to -1. -1 times -1 is 1. So, okay, let me back up. Let me back up and see what we did. And an I to the first power, you know it's I, correct? I to the first power, we know it's I. Anything raised to the power of 1 is that thing. And I to the 0th power, you know, is anything that you raise to the 0th power is 1, right? Okay, let me back up and see what we did. So we know anything raised to the 0th power is 1. I to the first power is I. I squared has one set of I times, there's one I times another I, which gives you I squared. So that gives you -1, right? Correct? Now what's I to the third is I squared times another I. So that means that -1 that we found, if you want to see the screen, go to YouTube. So that -1 that we found times another I. So that would give me -I. I to the third is -I. I to the fourth is what? I squared times I squared, which is -1 times another -1. Marquet, welcome. If you want to see the screen, go to YouTube. So I to the fourth is I squared times I squared, which is -1 times another -1, which gives you 1. Now, let me summarize what we found. So, and you'll see how to find. So our goal is solve for this in less than 30 seconds. I to the 3000. We're trying to solve for this in less than 30 seconds. Okay, so the first thing that we found is I to the 0 is 1. I to the first is I. I to the second is I squared, which is -1. I to the fourth is 1. So what's I to the fifth? I to the fifth is I to the fourth, which is 1. It's I to the fourth times another I. What's 1 times I? Come on, guys. Easy. What's 1 times I? I. There you go. That's what's up, Janelle. So that's I. So what's I to the sixth? I to the sixth is I to the fifth times another I. I to the fifth, we know it's an I, times another I, that gives you I squared. What's I squared is -1. Okay. let me go 7. I to the 7 is, and I'm going to stop there. I to the 7 is that -1 that I found times another I, which is -I. Now, notice what happened. Let me get this. Let me show you this on red. 1, I, -1, 1. So 1, I, -1, 1, I, -1, 1. There was a -I too, right? -I, actually. Ooh, I. Okay. So 1, I, -1, 1, I, -1, I. So all the answers that we found are either 1 or -1. They could be I or -I. So it's only 4 possible answer choices, Janelle. So the 4 possible answer choices when you raise I to any positive power is 1, -1, I, -I. So now when do we get which? So to find out when you get which one, what you do is you take whatever exponent that you have, you divide it by 4, the 2000, you divide it by 4, and the remainder gives you, so whatever you find for the remainder when you divide 2000 by 4, that's going to correspond to any of these first 4. So I'll show you what I mean by that in a little bit. I to the first, second. Okay, I'm missing I to the third. It's -I. Okay. I to the third is -I. So, let me go back. Let me go on the page. So, I to the 0 is 1. I to the first is I. I to the second is I squared is -1. I to the third is -I. I to the fourth is 1. I to the fifth is I. I to the sixth is I times I squared, -1. I to the seventh is -I. So it alternates 1, I, -1, -I. 1, I, -1, -I. So these are the only 4 possible answers we're going to have. So 1, I, -1, -I. So it's a pattern, yes. So there's a shortcut. And yes, good job. So now oh Lord. I don't know what's going on TikTok. I want you to know. TikTok always banned my live. I don't know why. Okay, so 1, I, -1, -I. So what you do is you divide I to the 2000. You divide the 2000 by 4. 2000 divided by 4, what does that give you? So 2000 divided by 4, whatever the remainder is, when you divide 2000 by 4, the remainder is 0. So because the remainder is 0, so that means it corresponds that I to the 0. You just relate it to I to whatever the remainder is. There are only 4 possible remainder when you divide a number by 4. 0, 1, 2, 3. So if the remainder is 0, you're going to correspond. So I to the 2000 is the same thing as I to the 0, which is 1. So I to the 2001 is the same thing as I to the, because the remainder is going to be 1 when you divide 2001 by 4. The same thing when you do the long division is the same thing as I to the first, which is I. And I to the 2002, and you can see where this is going. I to the 2002. When you divide 2002 by 4, the remainder is 2, is the same thing as I squared because the remainder is 2, and I squared is -1. I to the 2003, same thing as I to the third. I to the third is -I. And those are all the four possible choices. So whatever big number you have, you divide it by 4, and whatever the remainder is, if it's 0, 1, 2, or 3, you said you relate it to I to the what? I to the 0, I to the 1, I to the 3, I to the 3. So yeah, that's about it. All right. I think this should do it for now. And I appreciate you guys coming by. And I look forward to talking to you another time. And thank you very much for your time. Thanks. Black Tutors of Social Media. Thank you for stopping by. Kate, Bankroll, thank you. Thank you guys for stopping by. And I'll catch you guys another time. Bye.